Buenas noches, good evening, everybody. Welcome to day one on week 8 of the semester. The last thing that we talked about last week was the calculation of oxidation numbers for a given reaction in order for us to understand how to determine which element in a chemical reaction was oxidized and which one was reduced. This information is the last concept of chapter 5 that will be in the exam. So whatever material for chapter 5 that we covered today, it is not in the exam, or I should say any new material. So again, oxidation number is the last concept from chapter 5 that will be in the exam. This is just a recap on the last thing that we talked about. So there are basic rules for determining the oxidation numbers given a chemical reaction. And as you can see, there are outlined in this slide. So to review oxidation number, let's actually do at least a couple of more practice problems so we can solidify that last concept in order to prepare ourselves for the exam. Remember that on Thursday this week, for lecture, when I see you guys for lecture, is going to be a review for the concepts. For exam 2 is going to be, again, a Kahoot quiz that is going to allow us to review topics from the rest of chapter 3 that was not covered in the first exam, all of chapter 4, and then in chapter 5, from the beginning up to oxidation number. So let's get started. So when it comes to oxidation number, it is important to note if I have elements by themselves, if I have ionic compounds, and if I have covalent compounds. So let's do the first problem together. So one of the rules that we have there, let me just go back to the slide so you guys see it. An element by itself has an oxidation number of 0. Diatomic elements are also included in that list of being elements that have an oxidation number of 0. So if I go to the following reaction, which again, as a review for the exam that you guys have this week, reaction number 1, what kind of reaction is it? Take a moment, look at the reaction. We have magnesium reacting with HCl, making magnesium chloride and H2. What kind of reaction is that? Is it combination or synthesis? Is it decomposition? Is it single replacement, double replacement? Thank you, Kiyomi. You're correct. That is a single replacement reaction. For those students that are like, wait, I don't understand how that goes. Remember that in a single replacement reaction, what happens is that a single element is going to replace one of the elements that were in the compounds in the reactant side. So you can see that when we look at the product, magnesium took the place of hydrogen, and now hydrogen is by itself. So that's how we know that magnesium replaced hydrogen in the partnership that it had with hydrogen. So sorry, that it replaced hydrogen, and now it made a partnership with chlorine. And that's why we see it in the product, okay? So in this single replacement reaction, let's first identify who is going to have an oxidation number of 0. Let's put it in the chat. In the reactant, who's going to have an oxidation number of 0? Magnesium or HCl? Let's put it in the chat. Oxidation number of 0. Great job, you guys. Magnesium is the one that is going to have an oxidation number of 0. Okay. When we look at the product, who's going to have an oxidation number of 0? Great job, Isaiah. H2 is going to have an oxidation number of 0. Because remember that diatomics are going to be counted as a single element, and they have an oxidation number of 0, okay? Now, when we look at HCl versus magnesium chloride, which one is an ionic compound? Let's put the chemical formula in the chat. Who's an ionic compound? We cannot forget about that, even though that was in the first exam. Thank you, Vanessa and Guillaume. Exactly, magnesium chloride. So according to the rules for ionic compounds, their charge is going to be their oxidation number. So if I take magnesium chloride and I break it down back to its charges, magnesium is +2, chlorine is -1. So that means that magnesium is going to have an oxidation number of +2, sorry, and chlorine is going to have an oxidation number of -1. Okay? So in HCl, which is a covalent compound, we have to look at the oxidation number of the second nonmetal first. If we go through the rules, we can see that halogens have a -1 oxidation number, okay? Unless they're paired with oxygen. But in this molecule, we don't have a halogen paired with oxygen. So what is going to be the oxidation number of chlorine? Let's put it in the chat. Awesome. -1. So we can see that HCl doesn't have an overall charge. So when we add the oxidation numbers of Cl and H, it must equal 0. If you're wondering where that rule comes from, it comes from down here. The sum of the oxidation numbers for a neutral compound equals 0. If you're ever wondering, how do I know, Dr. Luz, what is a neutral compound? Well, a neutral compound is not going to have an overall charge in the corner. That's what we mean by that. So going back to the problem, since I have 1 chlorine and I have 1 hydrogen in HCl, what is most likely the oxidation number of hydrogen that when I add it to -1, it equals 0? So what is the oxidation number of hydrogen? Great job, you guys. Excellent. It's +1. Now I make my table. I say, well, I have reactants. And I have products. I'm going to investigate the oxidation number, specifically for magnesium, for hydrogen, and for chlorine. So magnesium in the reactant has an oxidation number of 0. Hydrogen has an oxidation number of +1. Chlorine has an oxidation number of -1. In the products, magnesium is a +2. Hydrogen is a 0, and chlorine is a -1. Okay, so I mentioned to you guys last time that when it comes to determining reduction and oxidation, remember that all the values to the left of the 0 are negative, all the values to the right of the 0 are positive. So anytime we have fluctuation of numbers going in this direction, which could mean it was a positive oxidation number and it went to 0, or it was a positive oxidation number and it went to negative, or it was at 0 and it went to negative. All of that means reduction. Then, if anything is going in this direction, meaning it started as negative, it turned into 0, or it had an oxidation number of 0 and it went into positive, that is called oxidation. Okay? So, here, chlorine didn't change. And we have a specific name for atoms that do not change in terms of their oxidation numbers. What is that termed? Thank you, guys. The spectator ion. That spectator ion is just sitting there looking at the action of the exchange of the electrons, but is not participating. Okay? So let's first identify, you guys, who got reduced out of this, meaning something that was positive and now it's less positive. Great job. Hydrogen undergoes reduction because it was, let's say, +1, and then it went to 0. So it did this. So if hydrogen undergoes reduction, that means that magnesium is what got oxidized. And when we look at this, makes sense. It was at 0 and then it became positive. So that's why it undergoes oxidation. Put a 1 in the chat if you want to do one more problem. Great. Put a 2 in the chat if you guys want to do it by yourself. Put a 3 in the chat if you want me to work it out. So 2 in the chat if you want to work it on yourself and we go over the answer. Put a 3 in the chat if you want me to go step by step. Okay, excellent. But you guys are going to help me go through the answer. So first, let's identify oxidation number, okay? So let me ask you guys this. In the reactant, which one has an oxidation number of 0 because it's an element by itself? Let's put the chemical formula in the chat. There are 13 students here. I only have about 3 answers. Yes, I agree with you guys. The Cl2 has an oxidation number of 0. What about in the product? Who has an oxidation number of 0? Great job, the Br2. Now, when we inspect NaBr and NaCl, what kind of compounds are we dealing with? Ionic or covalent? Put in the chat I or C. What kind of compounds are NaBr and NaCl? Great job, you guys. Exactly. They're ionic compounds. So remember, for ionic compounds, their charges are going to be their oxidation numbers. So what is the oxidation number of sodium? Let's put it in the chat. Oxidation number of sodium. Excellent, +1. So again, the charge is their oxidation number. So what would be the oxidation number of bromine? Not -2, bromine lives in 7A. There you go, -1. When it comes to NaCl, what's the oxidation number of sodium? Sodium lives in 1A. Excellent. Thank you guys. +1. And what about Cl? What is its oxidation number? Great. -1. Now let's make the list. Oxidation number at reactants and at the product. Okay. What am I going to investigate? I'm going to investigate Cl, Na, and Br. So at the reactant, Cl started at 0, Na was a +1, Br was a -1. In the product, Cl is a -1, sodium is a +1, bromine is a 0. So going through that, let's first do who got oxidized. And look at the number line. Let's put the symbol for the element that got oxidized. So proud of you guys. Exactly. Bromine. It was negative and now it has an oxidation number of 0. So bromine was oxidized. What about reduction? Who got reduced? Sodium or chlorine? Great. Chlorine. Give me one moment. This logged out. Great job. Any questions on oxidation reduction? Or how to determine who gets oxidized and who gets reduced? And remember, the elements that get oxidized and reduced are always in the reactant. So if you had to fill in the blank in terms of words, the answer, for example, for number 1, it will be elemental magnesium, okay? Not magnesium in Cl2. The reason why the answer is not magnesium in Cl2 is because that's in the product. Remember that who gets oxidized and reduced is always the reactant. And then who gets reduced in reaction number 1 is going to be hydrogen in HCl, not diatomic hydrogen or molecular hydrogen. Okay, remember that we always refer to the elements that get oxidized and reduced in terms of where they at in the reactants. Okay. Great. Since there are no questions, again, this is the last topic that is going to be in exam 2 when it comes to the concepts of chapter 5. Let's now move on to talk about the next concept, okay? When it comes to oxidation reduction, but specifically when it comes to organic chemistry, which is what we or what we talked about in chapter 4. So oxidation reduction reaction in organic chemistry, we are not going to be looking specifically at the electrons and oxidation numbers and all that kind of stuff. In organic chemistry, oxidation means that we are going to increase the number of carbon-oxygen bonds by the addition of oxygens, or it could be the loss of hydrogen. Reduction, on the other hand, is going to be specifically when we reduce the number of bonds between carbon and oxygen atoms. So when it comes to this, I want you guys to basically learn this in terms of what are the transition in functional groups. So since you guys know how to identify functional groups, and that's one of the concepts that is coming in this exam, that's how I want you guys to target these type of questions, okay? So when it comes to oxidation reduction, I want you to understand that whenever things are getting oxidized, okay, that is going to be the forward arrow. Okay? Then, if things are getting reduced, it's going to be the arrow going in the other direction. That's reduction. So overall, this is how I want you guys to know oxidation and reduction reactions. In this class, you guys are not going to be able to predict the products in terms of drawing the reactions, but you will be able to identify a particular functional group. So let's get started. If we start with an alcohol molecule, specifically a primary alcohol, what makes something be called a primary alcohol? Well, if the carbon atom that is holding the OH is bonded to one carbon chain, that's what makes it primary, okay? So a primary alcohol, when it gets oxidized, is going to make an aldehyde. That aldehyde, in turn, it can also undergo oxidation and make a carboxylic acid. So again, primary alcohol oxidizes to an aldehyde, aldehyde oxidizes to a carboxylic acid, okay? Now, primary alcohols, depending on the strength of the oxidation agent, they can turn all the way to carboxylic acids. And typically, if you have a very strong oxidant, you are going to be able to do that, okay? Now, reduction is going to be, again, the opposite of oxidation. And what is going to happen in reduction, as you can see, is that we are going to reduce the number of bonds between carbons and oxygens. So if we look at the reverse reaction, carboxylic acids can be reduced to aldehydes. Aldehydes can be reduced to primary alcohols, okay? Another reaction that I want you guys to be familiar with is, what about if I have a secondary alcohol? And what makes that second molecule a secondary alcohol is going to be specifically that the carbon atom that is holding the OH is attached to one carbon chain and a second carbon chain. So in a secondary alcohol, the carbon that is holding the OH needs to be bonded to two carbon chains in order to be considered secondary. So what happens when a secondary alcohol gets oxidized? We form a ketone. And when a ketone gets reduced, it forms a secondary alcohol, okay? So again, when it comes to this, what I want you guys to know is the conversions in terms of the functional groups. You guys are not going to be predicting the products. This is more of an exercise of, can you relate the functional groups to oxidation or reductions in organic chemistry? Any questions about oxidation and reduction in organic chemistry? Great. So one of the things that you guys may have noticed in the reactions that we have is that at times the reactions are going to have these digits in front of the compounds in a chemical reaction. The reason why that is because with those digits, we are going to have a balanced chemical equation. So in a balanced chemical equation, no atoms are going to be lost or gained, and the number of atoms in the reactants are going to be equal to the number of atoms in the product side of the reaction. This is all based on the law of conservation of mass, which indicates that is in an ordinary chemical reaction, matter cannot be created or destroyed. No change in mass, in total mass should occur, and the mass of the products in an ideal system is going to equal the mass of the reactants. So you guys can see here, this is a combination reaction. Silver is reacting with sulfur, making silver sulfide, okay? And you can see here that we have the mass for silver, we have the mass with sulfur, and then we have the mass of silver sulfide. When we pay attention to all of this, we can see that when it comes to the combination, because that's the type of reaction that is happening, between these two elements to make that ionic compound, the masses are going to be adding in the reactant and the product, and that's what's going to equal what we see in the product, okay? So understand that when we have chemical reactions, it's very important that we respect the law of conservation of mass, and we always have the same number of atoms in the reactants and in the products. So when it comes to balanced chemical equations, I cannot stress enough how important it is for you guys to practice, okay? You can have problems from the textbook, you can do the in-class worksheet. So the key to success in learning how to balance a reaction, even though we're going to go through some problems here, is that you guys practice, practice, practice. So these are going to be some general guidelines to how to write a balanced chemical equation or chemical reaction. First of all, you're going to start by listing the elements on the left and on the right side of the equation. So this is why it's important that you don't forget about naming ionic compounds. So even though exam 2 only has naming for covalent compounds, understand that in exam 3, you must remember all of the naming, okay? Because it's going to be part of the test. I want to make sure that you guys know how to name compounds. But again, we don't have to worry about it for the exam this week. We will go back and review it for exam 3. Then you're going to count the number of elements on the left, which means on the reactants, versus the right, which is where the products are. we are going to be balancing equations by adding a large number in front of the compound or element of interest, okay? We're going to start adding numbers with the lowest possible first, okay? It is a good guideline to aim for even numbers. You don't have to stick to only even numbers, but it's at least a good start. And understand that the last thing that we will balance in a reaction is going to be the elements that are by themselves. Understand that we need to put the large digits, as it was suggested in step 3, in front of the whole compound. We must never change the subscripts, because remember that changing the subscripts is going to change the identity of the compound. So right now, let's actually practice going from reaction in words to writing chemical equations. So we have the following problem when it comes to practice balance equations. Okay, so I want to make sure that you guys remember for this particular reaction, even though in exam 1 is when we did ionic, we just need to remember it for right now and make sure that we review it and solidify it by exam 3. So let's get started with potassium oxide. Okay. Let me see who recalls naming ionic compounds. Potassium oxide. Let's put it in the chat. What is the chemical formula? Come on, at least give me the symbol of potassium. Thank you, Dominique. Yes, K. So if it's paired with oxide, thank you, Nikki, exactly. Potassium oxide is K2O. That is in solid form, okay? Because of this word. Let me just highlight it so you guys see it. So solid is solid right here. And then potassium oxide, you can see the chemical formula. Then we have water. Come on, I know you guys know this. What is the chemical formula for water? Excellent. Make sure that if you have to enter chemical formulas, you guys don't put H20. Because remember that Canvas is going to know the difference between a capital O and a 0. And writing a 0 is incorrect. So make sure that you put a capital O. Be careful with that. So when it comes to water, thank you for putting that in the chat. We have H2O, and that is in liquid form. So I'm going to put a little L right here. Now, as a product, I'm going to form potassium hydroxide. So I'm going to put an arrow. And then I have potassium hydroxide. What is the chemical formula for that? Great, KOH. So now we're going to look at the number of atoms, okay? In the reactants, I have potassium, I have oxygen, and I have hydrogen. In the products, I have potassium, I have oxygen, I have hydrogen. So when it comes to the potassiums, we have 2 potassiums. When it comes to the oxygens, two oxygens. Lastly, we have the hydrogens. Two hydrogens. okay? When I look at the product, I have 1 potassium, 1 oxygen, 1 hydrogen. Put a 1 in the chat if my counting of the atoms makes sense. Excellent. So as you guys can see, we have more atoms of potassium, oxygen, and hydrogen in the reactant compared to the products. We actually have 2 in the reactants, but then we have only 1 in the product of each. In order for us to match them, all we need to do, you guys, is to put a 2 in front of KOH. What that does is that now that 2 will be distributed to all of the atoms. So now we are going to have 2 potassiums, 2 oxygens, 2 hydrogens. And as you can see, the number of atoms are balanced. Okay? Let's do at least a couple more. Let's do number 2 together. We have solid aluminum. What is the chemical formula for aluminum? Great job. Al. And then if I have oxygen gas, remember that oxygen is a diatomic. So whenever we have them, whenever we have oxygen in a chemical reaction, we have it as O2. Please, in a chemical reaction, you guys, never put it as an O by itself. It's always O2. Okay? Thank you, Maria. Exactly. It's O2. Now, the product of this, oh, let me just put the states. So this is a solid, this is a gas. The product of this is aluminum oxide. What is the chemical formula for aluminum oxide? Excellent. Al2O3. So let's do the count for the elements. I have aluminum and I have oxygen. In the reactant, I have 1 aluminum, I have 2 oxygen. In the products, I have 2 aluminums and 3 oxygens. Okay? So at first, you may be tempted to say, okay, let me balance my aluminums. And then at that, you're going to say, okay, let me put a 2 on aluminum. That's going to take the aluminums to 2. And at least that part is balanced. Then we deal with the oxygens. So if you put a digit of 2 before the oxygen, then that's just going to affect the number of oxygens on the reactant, but you will still be short on oxygens. Meaning, if you put a 2 here, that means that your oxygens now go to 4. And then you may be like, wait, but then the aluminums are okay, but the oxygens are off. Okay? Put a 1 in the chat if so far you understand why I put 2s. Now, because just putting these digits in front of the oxygen still makes the oxygen not be having the same number of atoms in reactants and products, then we have to think about, well, since I need more oxygens, the only way that I can get more oxygens is if I put a coefficient in front of the aluminum oxide. So if I put a 2, because it already has a 1, okay? So if you don't have a digit in front, that means that there's a 1 right there. So if I change my aluminums to 2 in order to increase my oxygens, then I notice that my aluminums will go to 4. My oxygens will go to 6. So maybe putting those 2s is not a great idea. So let me take them away. But let's think about it now. By putting that 2 before aluminum oxide, I can just go back to the reactant and say, well, if I want to match the aluminums, all I have to do is put a 4 in front of the aluminum. Now I have 4 aluminums. If I want to match the oxygens, well, since I only have 2 and I need to get to 6, oh, 2 times 3, that equals 6. So if we put a 3 here, my oxygens go to 6. And as you can see, you have the same number of atoms in reactants and products. I'm going to give you guys a few minutes. I want you to try problem 3. Okay? So look at the name. If you don't know the chemical formula, it's okay. We are online. Just go ahead and Google it. But write those chemical formulas for each of the components of the reactions, unless balance reaction 3. In the in-class worksheet, there's a lot of problems when it comes to balancing equations. So you guys can practice as much as you want when it comes to that. So let me give you guys about 3 minutes to solve this problem. Okay, let's go over the answer. Sodium peroxide has the chemical formula Na2O2. That is an aqueous form. Water has the chemical formula H2O, and it's in liquid form. Then we have sodium hydroxide, which is NaOH. That's an aqueous form. And lastly, we have oxygen gas, which is O2, and we put a G. Put a 1 in the chat if you at least have part or the whole chemical formula correct. Good. Good to see that. Now, when it comes to this, we're going to have sodium, oxygen, and hydrogen on each side. Sodium, oxygen, and hydrogen are the atoms that I have. So when I look at the reactants, I specifically have 2 sodiums, I have 3 oxygens, I have 2 hydrogens. In the product, I have 1 sodium, 1 hydrogen, 3 oxygens, okay? Put a 2 in the chat if you got the same numbers in the beginning when it comes to the number of atoms. Love to see those 2s. So at first you may be wondering, okay, where should I start? And when we look here, we should notice that specifically our oxygens look balanced. Your hydrogens is the ones that is unbalanced. But when we look at the product, at first we're going to say, okay, I only need to increase my sodiums and my hydrogens by 2. The compound in the product that has the sodium and the hydrogen is sodium hydroxide. So at first you can propose to put a 2 right here. When you do that, that's going to take your sodiums to 2, your hydrogens to 2, but when I do that, then my oxygens went to 4. Okay? So now you may be tempted to say, okay, so since my oxygens went up, I can basically increase my oxygens to 4 on the reactant. How do I do that? Well, if I put a 2 in front of the water, then that means that I have 2 oxygens in the water because it's 2 times the 1 in the subscript, and then I have 2 oxygens in the sodium peroxide. Now my oxygens are up to 4, but then you have to realize that putting that 2 before the water now took your hydrogens, okay, up to 4 hydrogens. Okay, and we only had 2. So at this point, again, when it comes to doing balancing equations, it's just trial and error, you guys. So at this point, you have to tell yourself, well, maybe that 2 is something that I need to change when it comes to the sodium hydroxide. What about if I try to balance my hydrogens and I put a 4 before sodium hydroxide? Well, if I put a 4 there, that means that I have, instead of 4, I will have 6 oxygens in the product. My hydrogens will go to 4. But what's going to happen to my sodium? It will also go to 4. Okay? So at this point, my hydrogen is balanced, my oxygens are off, but then my sodiums are off too. Well, let's try to balance the sodiums. If I put a 2 in front of sodium peroxide, my sodiums will go to 4 atoms. Okay. Now, when I look at my oxygens, instead of 4 overall, I have 6 of them overall. How do I have 6? Let me just make some markings here. This 2 gets distributed or multiplied with this 2. So that will be making oxygen before here. Then, because of this 2 times the 1 that is in the water, that will be oxygens equals 2. So the 4 here and the 2 here, that's where I get my 6 oxygens. Okay? And now you can see that on both sides of my chemical reaction, I have 4 sodiums, 6 oxygens, and I have 4 hydrogens. Okay? So the O2, we didn't put a digit, which is called a coefficient in front of it, but technically it has one. If you didn't place a digit in front of it, it's going to have a coefficient of 1. Questions about problem 3? Make sure that you practice balancing equations. Again, when it comes from words to writing the chemical formula to balancing the reactions, we have problems like that in the in-class worksheet. There's also a problem in the in-class worksheet where you have just the chemical formulas and you just need to put the coefficients in order to balance the reactions. I want to make sure that you guys know how to do both. Since there are no questions about balancing equations, let's proceed to the next section in chapter 5, which has to do with the last part of organic reactions, which are condensations and hydrolysis. Okay, so when it comes to reactions of organic chemistry, meaning condensations and hydrolysis, let's understand what is the difference between a condensation reaction and a hydrolysis reaction. Okay, so the condensation reaction is the one that we have on the left. This condensation reaction basically is going to take 2 functional groups, which happen to be OHs, and is going to make 1 molecule. So in a condensation reaction, because we are creating 1 product, it's kind of like a combination reaction, but it's just that we call it condensation because our reactants are going to be organic molecules. And remember that organic molecules are going to be those molecules that contain carbon. Okay? So anytime you have 2 molecules, okay, and you see them glued together to make 1 product, that is called the condensation reaction. Now, we can also have hydrolysis. And in a hydrolysis reaction, understand that what hydrolysis means is that this is, quote unquote, cutting with water. So we're going to take a single molecule and we're going to cut it with water, okay? How we're going to cut it with water? Overall, understand that a water molecule, what's going to contribute is that the OH in your water is going to go to a section of the molecule. The H in the water is going to go to another section of the molecule. So you can see that in the molecule given, this is an ether. If an ether is actually, let's say, undergoing hydrolysis, and this is just illustrating an example, okay? We see overall that a part of the molecule got the H, and the other part of the molecule got the OH, okay? So again, for the purposes of this class, it is important that you guys identify functional groups. So understand that overall, what I want you guys to do is visualize what is happening in terms of the functional groups. So in order to do this, as you can see, we have a series of reactions, and I'm going to go through all of them. And you guys need to be able, for the third exam, to identify condensation versus hydrolysis versus oxidation versus reduction, which are all the reactions that we have discussed so far in terms of organic chemistry. Okay, so these are just some examples of typical organic reactions that can be classified in any of these four groups. Let's go through the first pair. Okay, in the first pair, when it comes to functional groups, this is a carboxylic acid. This molecule is an alcohol. Then understand that you have one molecule and you have another molecule, and we're making a single product, which is an ester. So the classification for this organic molecule is going to be condensation, because I have two separate functional groups clicking together to make a single product, okay? Sometimes you can get a hint by saying, oh, the new product is going to be plus H2O. It's just that it wasn't illustrated here. That is also an indication of condensation, as you can see it here. Water is produced in a condensation reaction. It's not part of the reactants, but it's part of the products. Let's look at the functional groups for reaction B. Let me see if we remember our functional groups. This is coming in the exam this week. What is the functional group where we have a C double bond O bonded to nitrogen? What is that called? Let's put it in the chat. Great job. Thank you, Katie. This is an amide. And I already established to you guys that on letter A, a C double bond O with OH, that's a carboxylic acid. Whenever we have a nitrogen with R groups, remember that R groups are rest of molecule. It could be hydrogens or it could be carbon chains. This represents an amine. But look at this hint. I have an amide, and then on the arrow, or sometimes you can see it as plus H2O, we have H2O as a reagent. So I have one molecule Since in the reactant I see water, that means that water is going to be cutting this molecule. How is it going to be cutting it? If I write water as HOH, this OH is this. This hydrogen is right there. Okay? So when it comes to the classification, this is called a hydrolysis reaction. Okay? Let's go over letter C. Okay? I explained earlier in today's lecture, when I have a carbon atom with two hydrogens and it's holding an OH, what if it's bonded to one carbon chain? So remember, R means rest of molecule, meaning this is going to be a carbon chain for the most part. So if I have a carbon chain bonded to a carbon that is holding the OH, that is a primary alcohol. And this primary alcohol went to forming an aldehyde. So if you look at the notes of something that we were talking about earlier today, okay? When a primary alcohol goes to an aldehyde, is that oxidation or reduction? Let's put it in the chat. When a primary alcohol is converted to an aldehyde, is that oxidation or reduction? Excellent. Yes, that is an oxidation. So these letters that you see here, PCC, this is just the reagent for the oxidation, which is what's happening of that primary alcohol to an aldehyde. Okay? Any questions on A, B, or C? Let me see if you guys are following. What is the functional group in the reactant for letter D? What is the functional group in that compound that I put a check mark on? Great. That is a ketone. And as you can see, we have some reagents there. You guys don't have to memorize the reagents. For me, it's important that you guys know the functional groups. A ketone went and formed an alcohol, specifically a secondary alcohol. Okay? So when I have a ketone being converted to an alcohol, is that oxidation or reduction? Great job, you guys. Excellent. This is reduction. Let me just put it on the side. So this is an oxidation reaction. This is a reduction reaction. Lastly, as you can see, we have two components, a carboxylic acid. We have an amine. We form an amide. This means that we are losing H2O. That's why you have that negative right there. Okay? So that means losing H2O. So we have two functional groups that then is fused together to make a single functional group in the product. So out of all of the reactions that we have discussed so far, A, B, C, or D, what is the classification of E? Is it condensation? Is it hydrolysis? Is it oxidation? Or is it reduction? What do you guys think? Which one of the four? Let's just pick one. Great. I see condensation. Who else? I have 13 students here, only 2 answers on the chat. Remember, 2 functional groups that turn into 1. 2 functional groups that we turn into 1. Great job, you guys. Thank you for answering condensation. So again, condensation is when I have 2 functional groups turning into a single functional group in the product. Hydrolysis is when I start with a functional group and I split it into multiple functional groups, like in example B. Oxidation and reduction, remember that those reactions specifically have to do with slide 15. Okay, and it's just that relationship of primary alcohols to aldehydes, aldehydes to carboxylic acids, and vice versa, or secondary alcohols to ketones. So it is important that you guys know how to identify the functional groups in order to do this classification. Any questions when it comes to classification of condensation, hydrolysis, oxidation, or reduction? Great. Since there are no questions, this is the end for the class today.